hello everyone. This is the weekly CNCF Harbor meeting. Today is the 10th of July. Welcome everyone. Let's get started. So before we get started, I'm sharing the community board where everyone can add their topics for the today meetings. And I'm going to share this one again as well. Okay, wait just a minute. Okay. Here is the link for everyone. Please add yourself to the board. And if you're new, introduce yourself. Okay, so for today, there is nothing on the agenda yet, but I know already one of the topics. So do we have some new faces? We have a few new faces. If there are people new today here, if you would like to introduce yourself, please go ahead, unmute yourself and introduce yourself. Who would like to know who you are? And in the meantime,
hello everybody. Am I audible? Hi everybody. Okay, my name is Industry and I'm from India. Yep, I'm involved in managing our organization's container registry by supporting our internal project needs. So yeah, this is my first time. Yeah.
Okay, what organization?
Mercedes-Benz.
OCD expand or so I didn't understand this. What was the name?
Mercedes-Benz Research and Development.
Ah, Mercedes-Benz. All right.
India.
Okay.
Yeah.
Okay. All right. Welcome. So
Thank
you're a
you.
colleague of Alexander, right?
Yeah. Right.
Okay. All right. Good. Do we have anyone else who would like to make introduction?
It's also me. I'm Spiros. I'm a computing engineer at CERN. I'm a colleague of Diogo that used to join some time ago. And we have a private registry for the wider community that we support around the physics. So it's public in a way that we have unknown users, but private in the sense that it's not open to everyone.
Okay, welcome. Welcome. Okay, so I have already the board updated to the today's topic, so you're free to add your points you would like to discuss, your questions, your discussion points, and we have already Roald here who would like to share his notes or updates on Harbor Satellite. So for the background or for context, Roald was the mentee for Harbor Satellite in the first half of 2024. And he was working on Harbor Satellite, which is an edge registry. And he would like to explain you and show you what a satellite is and how it works, and also what he contributed to Harbor Satellite. Are you ready, Roald?
Yes, hello. So let me get my presentation ready and I'll share my screen with you. And share.
Yep.
Yeah, okay. So as Vadim said, yeah, I was the first mentee on this Harbor Satellite project. So well, my name is Roald Brunel, so I'm a computer science student right now. And I was able to work on this project for the last 3 to 4 months. And I joined at the very beginning of the project. So we went from at the start defining the first use cases of where Harbor Satellite would be useful, what kind of customers it would answer to. And then we conceptualized a few architectures, possible implementations. And then I was able to implement one of them until we got a working proof of concept. So let me talk a little bit about the background. So why does satellites exist? And it comes because in recent years, there's been a whole extension of containers where traditionally they were used very much in cloud environments, and they're more and more being pushed towards edge environments, and they're being more and more useful in those environments. And those specific environments have one major problem related to internet connectivity, because some edge environments do not have a reliable connection, or if they have a connection, it might be spotty or have poor bandwidth. And in those specific cases, traditional cloud-centric container registries and management solutions can have quite a few challenges of managing, running, updating all those containers. So that's kind of where satellite comes in. It wants to answer that specific problem that is becoming more and more prevalent. And in order to do this, I've found two main goals. The first one is being, of course, to decentralize these container registries, take them away from those central cloud-based solutions, and push them closer to the edge computing environments where all this data is being produced and processed, which in and of itself also brings a few bonuses like less latency and overall improved performance. And the second goal is to have the solution be completely independent, meaning that it can operate forever in those edge environments, whether there is an internet connection or not, and it can keep on serving, managing, and those IoT devices that are on the edge. So the first use case we found, the first architecture we conceptualized, is the traditional one, which I've kind of already mentioned, where you have several IoT edge devices that are running perfectly fine, and suddenly the internet connection breaks down or becomes too bad to keep on working with the remote registry. And in that case, then Harbor Satellite comes in and becomes the middleman and takes up the slack and continues managing those containers, serving images, and all of that. So this is the first use case that I've actually been able to implement. And so what the satellite basically does is when it's first deployed, it's going to retrieve a list of images, either directly from the remote registry or from another component that is getting developed right now, which will give it a list of images that it needs to pull from the remote registry and push to a local registry. Now, this local registry, we have currently two options for consumers. So either we give it, we give a ZOT registry that comes with the satellite that can launch automatically with the satellite, or you can come in and bring your own registry. And yeah, once the satellite has pushed all the necessary images to the local registry, it's going to serve them to all the local devices who need those images. And whenever the internet connection comes back, then the satellite will connect to the remote registry or the route control component and basically update all the data it needs, all the images, all the configurations, etc. And then be able to keep on serving the local images. But we also do not want to limit the devices to have to go through the satellite. There is also the possibility to directly connect to the remote registry and skip the satellite, and then the satellite would only be enabled in case there is internet problems. So that's the first architecture, the one that I will demonstrate in a few minutes. But I also wanted to talk about the second architecture, which I found interesting. So in this one, it's more aimed towards large-scale edge computing, where you have many thousands of devices, and a single registry, like the previous use case, will not be able to serve all of them. So here, the satellite is a little bit simplified. Its main job is to send out polling instructions to a cluster of nodes. And these nodes are composed basically of one registry and a Spagel node, which means that they can pull images from a remote registry after receiving the instruction from the satellite, and then automatically spread them around the cluster to make them available all through the cluster and to many, many more devices. So this is still very conceptual, and it's going to be implemented further down the road. First, we focus on the first architecture. And final part before the demonstration, just a few mentions of what technologies we are using. So the language is Golang, because it's a high performance language. It's got a pretty easy to understand syntax, and it's open source. But mainly the container management tools. So I've always used Harbor as my remote registry for all my tests, and used, as I said, the Zot registry for the local registry. And both of these have been good choices because they're OTI compliant, meaning that they fit perfectly into the ecosystem. They're both also open source, which makes them easier to work with. And lastly, for Zot, it also has the Go library, which makes the development a lot easier. And finally, we have Crane. So that's the tool that I've used to interact with all these container images or these registries. It's got a whole lot of features, from basic pushing and pulling to getting digests, getting manifests, etc., etc. There was a debate on maybe using Scopio, which is basically the open source alternative, but we opted for Crane since it has, again, a Go library, and that makes development a whole lot easier. So that's it for basically the presentation, and now I want to show a small demonstration. Let me see. Okay. So currently, I've set up a repository on the Harbor demo instance. It's currently empty. And down here, I've got Postman, who's going to contact the local Zot registry launched by satellite and basically show all the images. So I have satellite running in the background, and currently, every few seconds, it's going to basically synchronize the remote registry with the local one. So let me push an image to the remote registry. I'm going to see it appeared here. And if we now synchronize, we can see it's created a repository. And if we go into the repository, once it's finished downloading, there we go. The registry image has been copied. And now we can also add another image. There we go. Second image is online. The satellite will retrieve it in a few seconds. And there we go. It's been added here. And we can also delete images. If we come delete it from the online repository, give it a few seconds, and here we go. So basically, it acts as just synchronizes the online repository. There's also the function to give it a specified list of images, and it will just retrieve those specific images and update them when needed. So there we go. That is basically what I've been working on the past few months. And yeah, I'd like to thank Vadim, because it's been a very good experience for me. I learned a lot, and it's been great to also be able to contribute to this open source world, which is the first time I've been able to interact with.
Thank you very much. Thank you.
Thank you.
Thank you.
So as you can see, this is currently the first iteration, right? So we are not there yet. There are still some topics and areas that are in flux, meaning that they are not defined yet, and we need to discuss and define them once we are there. You know, one area which is always difficult in the edge space is the device registration, or kind of a registration, deregistration, and kind of a zero-touch operations. For example, that it can bring the satellite up without a lot of pre-configuration. So this is one area, and there is also the area of the management part, like how do you construct this list of images that should be on the satellite. And we are thinking here not about one satellite or two satellites, where one person can manage this, this list, but we're talking about hundreds and thousands of satellites, so you need kind of a grouping, labeling things, and you want to easily deploy your software on those thousands locations. So there's a lot of things to do and to discuss, and once we are getting close to that, we'll focus on that. In the meantime, if you have some feedback, ideas, or similar use cases that you think satellite can be used for, you can join the satellite harbor community. It's on the CNCF Slack channel. Let me paste the, well, maybe someone can paste the link to the Slack channel, so you can join the Slack channel. There is also a weekly meeting where we discuss progress, and also we discuss the architecture design. And if you would like to participate in that, feel free to join. And the current mentee is Prasant. He is now working on the ground control part. Okay, so this is from the satellite. If you have questions, please go ahead and Roald, me, and Prasant try to answer it. Okay, there's no questions. So let me bring up the board again, and then we can discuss other topics. So what do we have on today's agenda, right? So it's Harbor Satellite. Are there any topics from the community you would like to discuss or questions?
Hi, Vadim. I recall that you will help us to set up a new instance to host to the demo instance, right? So can you share the status?
Sorry, I didn't understand you. The connection is not very good.
I recall that you will help us to set up a new demo instance.
Oh yeah,
Can you share
right.
us the status?
Yeah. Okay, you're right. Yeah, I'll share the credentials with you. Yes. Okay, you're right.
I mean, you mean that you have already have to set up the new demo instance for Harbor?
Yeah, but I've created already. I just need to deploy it. But I tested it already and just need to do the deployment, the final one.
Okay, sure. Thank you.
Yeah. Okay, I'll share you with that. So are there any other topics you would like to discuss?
Sorry, I have one more question. Do you need us, because that we have already some set up script, do you wanna share the same set up script with you in your new Harbor instance?
Yeah,
Like
I'll
we
share
are
the
cleaning data every 2 days. Yeah.
Sorry, I didn't understand. So you
So,
have
I mean that I mean that we have already have some set up deploy script or clean up scripts. That that was executed automated and scheduled to every other day to clean data and restart Harbor. So if you want to share the same story, we can share the script with you.
Mm-hmm. Okay. Yeah. Yeah, that would be good. Mm-hmm. Okay. Then, so from the community, are there any topics you would like to discuss? I mean, I have a few topics I would like to take a look at, but if only if there is nobody else have something on the agenda. Okay. I have I found a few interesting PRs that been made from a user, and it's basically about the pipeline that we have, the make files. And I find them very interesting because they look quite promising. I need to verify and test them. So this is a small PR, but there is the trivia adapter build PR. So it basically changes it breaks up the Docker file, into one. So this is like and I think there is another one from this user. Let me just. There isn't, reduce file size. This is the major one, right? So this is basically a very interesting proposal because it changes the Docker files, but it doesn't change them really, but just the structure and make them in one operation. And I didn't know that, but that's apparently the case. So if you copy things and then you do a run, if you change ownership, you create basically two layers. So you duplicate your layers. And this is, of course, causing duplication of storage in this case. And you can avoid it if you just do it everything in one command, right? So here, and this is what he does basically. This is, for example, one Docker file that just corrects this. The same goes for the other one. It's all in this direction, right? And here is simplifying. And I find this interesting, and I also find other contributions from him interesting because they all go the same direction. And there's also the registry build part that optimizes it, and there is also the cleanup of makefile, right? So this is also very helpful because there's a lot of things that we don't use in a makefile, like the def flag is not used, a lot of variables are not used, and so he is kind of simplifying that to clean up the not necessary part, which I find interesting or helpful. I'll test this one, and I would like to get this makefiles merged into Harbor. There is, of course, another one which is interesting, the PR regarding the ARM files. This is from me, but there is also some other discussion going on in that space. I mean, this is also from me. It's about the so this is also regarding ARM, but it's more for the development side, not for the production side, because when you have it, when you develop on the Mac OS, for example, on a M1, and you want to build things locally, you cannot do this because you have, you accidentally build ARM images with x86 binaries, and this is basically a solution for that. So for local testing, this is the thing to, this resolves the problem. It's not for production because this spectral image is only used for the local development. And so with this one, you can run it on x86 and then ARM in parallel because it will build the proper image with the proper binary. Because otherwise it will build the image correctly, but it has the wrong binary inside. Okay, so that's from my side, the PRs. Are there any other topics from you guys? Okay. Well, if there are no topics, no discussion points, I think we can then close earlier today.
Yes, thank you.
All right. Thank you very much, everyone. And have a nice day and afternoon, evening, morning, wherever you are. Okay. Bye-bye, everyone.
Thank you.
Bye.
Bye. Bye-bye.
Thank you.
Thank you all. Bye.